My name is Ethan Marks, and this project is a machine learning model for the first round of the NCAA men's basketball tournament. This presentation and project were created for Python for Data Science, CSCI E29 at the Harvard University Extension School. This class was offered during the spring of 2018, and this was our teaching staff. Abstract. For this project, data, including experience and efficiency data for each team, was used to create a model that could predict whether a men's college basketball team would beat the Vegas spread in its first game of the NCAA tournament. The model created had greater than 50% accuracy. The two teams' efficiency ratings had significant predictive value, but one feature with the most predictive value was the experience level of the underdog. These are the required libraries and files. For this project, I used data for every game in the first round of the NCAA tournament from 2008 through 2017. For features, I used objective team efficiency and experience statistics from the website kenpom.com. These are the imports for this project. I began by reading in the initial data. This included data on the teams that played each game, their seeds in the tournament, the spread for that game, and the number of points each team actually scored in that game. The explanation that follows is for the 2008 data. I began by saving the 2008 data to its own data frame and keeping only the rows and columns I was interested in. I then created two new columns. The first column, titled Margin, contained the number of points by which the favorite in a given game beat the underdog. The second new column, titled Year, indicated the year in which the game was played. I knew that I eventually needed to merge different data sets that use slightly different wording to refer to the same team names. I made a few changes to the data to account for that. Then I read in my efficiency data for 2008. After reading in the data, I kept only the columns I was interested in. Then I merged the efficiency data with my original data set. I also wanted to include experience data in my data sheet. I read that data in and kept, again, only the columns I was interested in. I merged that data with my previous data set. Then I took the same steps with respect to the data for the other years from 2009 through 2017. Portions of those steps are shown here. I created a new data frame, including the data from each year. I checked to make sure I did not have any null values in my data frame. I created a new column for my target variable that included a 1 if the favorite beat the spread and a 0 if the favorite did not beat the spread. Then I explored the data. I also looked at how the data was correlated. I noticed a significant correlation between a number of my variables and my target variable. I also explored the data visually. Finally, I used a couple different classifiers to predict whether a favorite team would beat the spread in a given game. I also used a few different groups of features. After some experimentation, I achieved a relatively high level of accuracy by including only the experience level of the underdog team as well as the spread as features in my model. This model is shown below. For this model, my mean cross-validation score was about 0.547, and my median score was about 0.557. This model is shown here. This slide shows the confusion matrix classification report, as well as the cross-validation scores for this model. These results were interesting. They suggested that an underdog's experience level is very important in the first round of the NCAA tournament. Below, I've included a few other models that did not provide results that were as accurate as the model described above. These are the references I used for this project and presentation. This concludes the presentation. Thank you.